At this point, we've spent a lesson talking about slope. And the reason we took so long talking about slope is because it's an integral part of graphing lines in slope-intercept form, which is what we're going to be studying today. Let's set up some definitions for ourselves so we have an understanding of what we're talking about. So when we have slope-intercept form, you've normally seen this as y equals mx plus b. But just like we learned before, f of x stands for y. So we can now see f of x equals mx plus b or y equals mx plus b. But please remember that these equations must always be solved for y, meaning the y is by itself, for us to know our slope and our y-intercept. So the first thing we always have to check is that it says f of x equals or y equals. Once it's in that form though, it's really important that we're looking for that slope and that y-intercept. If you remember from last time, the slope is m. So this m right here tells us our slope in mx plus b, which is our rise over our run. So we have this graphic here with the up and down for the rise, and then to the right so that we run the correct direction. What the slope does is it tells us how we move across the graph. And I keep using the word move because it also starts with the letter M, so it'll help me remember that the M is how we move. That's our slope, the incline of the line. And then we have the B. The B is our y-intercept. Now, the reason that the y-intercept is so important is that it tells me where we begin, with a B, to graph. We can always begin at the y-intercept because it's a point we can find on the graph. From the beginning point, we can use the M to move. One word you're going to hear me call the B over and over again is the initial value. So your y-intercept is your initial value. Initial is a word that means beginning or starting. So it makes sense that where we begin to graph is our initial value or our beginning value. Now the steps to graph are really pretty simple. There are 4 steps here to graph a function that's already written in slope-intercept form. The very first thing it says to do is plot the y-intercept. Now we said in y equals mx plus b, which this equation is written in, the b, or the last number, is your y-intercept, which means we have a y-intercept at the coordinate 0, -3. Okay, so that means that we have a red dot for the y-intercept at -3. We've gone ahead and started right there. It then says to use the slope, which is m, to plot more points. I know my m is the number next to the x, so 2/3 is my slope. That's telling me that I'm going to go up 2 and right 3 and then plot more points. So from that beginning value, I would count up 2, boom, boom, and to the right 3, 1, 2, 3. I drew another dot. I repeat that same process, the same pattern, up 2 over 3. Up 2 over 3 until I'm confident that I can draw a straight line through those points. It usually takes me 2 or 3 dots to successfully plot my line that's straight with a straight edge. Then we take that straight line through all of the points, and you make sure you end it with arrows because that makes your math teacher happy. That let us know that that graph keeps going on in both directions and has a domain and range of all real numbers. Our goal today is to be able to graph these functions and then talk a little bit about important points on this graph. The vocabulary that you're going to need to use today is slope, which we've talked about. The slope is the rise and the run, or represented by the M, and on our graphic here, it's represented by the green steps, our rise and our run. That's our incline, our rise and run, how we move across the graph. We've also kind of defined these two already. You have y-intercept and initial value. These are essentially the same thing. Remember, they're the b from my equation. The y-intercept, though, is a coordinate, so we like to write these as coordinates, 0, b. The initial value is just the number. But remember, the y-intercept and the initial value is just where the graph crosses the y-axis. Where the graph crosses the y-axis. So in our picture here, it's shown in red. That is both our y-intercept and our initial value. The initial value is just the number, or the y coordinate, of the coordinate pair 0, b. Now, two new words that you may not know about are x-intercept and 0. Your x-intercept and 0 are also the same word. Your x-intercept is going to be where the graph crosses the x-axis. So it is also a location on our coordinate grid here, which means we're always going to give it as a coordinate for x-intercept, x comma y, or sorry, x comma 0. It'll always have partnered with a 0. And then since it's always partnered with a 0, it is called the 0. So in our picture here, we don't have it labeled yet, but we know where our x-axis is. So we know that our x-intercept would be right there where the blue line crosses the x-axis. That is also our 0. Quick recap, we have the slope, which is the m. It's the rise and the run, or of the incline of the graph. Y-intercept and initial value are both the b from the equation and are found when I look at the y-axis and see where the graph crosses it. The x-intercept and the 0 is not a number here, it's a vocabulary word, is where the graph crosses the x-axis. So I look on the x-axis to see where the blue graph crosses it, and that would be the coordinate of my x-intercept and the value of the 0. Let's do a couple practice problems together so that we can see how to graph these just a few more times. So we're going to graph the function and label its attributes. Okay, the first thing we need to do is find the y-intercept and plot it. Now we know that this equation is written in slope-intercept form because it's in the form y equals mx plus b. Our y-intercept is positive 4, which means this graph is going to cross the y-axis at 0, 4, which means it has an initial value of 4, because remember, these are the same. Sweet, that's easy. I go on the vertical axis, the y-axis, and I'm going to go ahead and plot my y-intercept. Check, I'm done. Then I'm going to use the slope to create more points. The slope here, the m of this equation, is -2. Now it's really nice when this is in fraction form because we need a direction to go up and down and to the right. So we're going to go ahead and write the whole number -2 as a fraction, -2/1. Those are equivalent, so that I now see the rise and the run associated with this graph. Starting at that y-intercept, I'm going to count down 2, bloop, bloop, and I'm going to go over 1, bloop. That's where the next coordinate point should be. I repeat that process, down 2, 1, 2, over 1, and I plot myself another point. I'm going to do this a few more times just because for me personally, I have a hard time drawing straight lines. So the more coordinates you have showing on your graph, the easier it will be for you to draw a straight line between them. Once I feel confident that I can draw a long, nice straight line that ends in arrows between all of these things, I'm going to find a straight edge. And this straight edge can be a ruler, it can be a piece of paper, it could be the side of your phone. And I'm going to put that straight edge down on top of my paper or my computer screen, and I'm going to draw a straight line. You should probably draw a better line than I did. But we have our straight line that goes through all of those points. And voila, we have graphed it. Now that we've graphed this, though, we do need to tell about the x-intercept and the 0. Remember, the x-intercept and 0 are essentially the same location on the graph, just two different vocabulary words to describe it. The x-intercept is a location, and it's where it's going to be crossing that x-axis. Well, my graph crosses the x-axis at the point 2, 0. And since 2 is partnered with 0, my 0 vocabulary word is 2. Quick recap. We started with the y-intercept or initial value. That's in red. Then we used the slope, written in green, to get more points, more coordinates along the line. We went down 2 over 1, down 2, right 1, down 2, right 1, until I felt confident that I could draw a semi-straight line between all of these points, put arrows at the end, and label all of my function's attributes. It's you guys' turn to try. You guys have number 2. I would like for you to try to tell me the y-intercept slope, graph the line, and then figure out all the rest of the function's attributes. Pause the video, give it a shot. So I've gone ahead and I've drawn my better straight line this time. I started at a y-intercept or initial value of -6, that's in red. And then I used the slope of 3, which means I'm going to rise 3 and go to the right 1 in between each point to plot more purple points. From there I was able to draw my nice, actually straight blue line between here. All that's left is to make sure I have this correct x-intercept and 0. But remember, for the x-intercept, I'm looking for where the graph crosses this flat or x-axis, and I can see that I have a coordinate point on the value of 2 again. 2, 0 is my x-intercept, which means the 0 of this function is 2. That's right there. We double check real quick to make sure we have all of our function's attributes labeled correctly, and we're happy and good to go. Now something different is going to happen with number 3 and 4. We'll walk through number 3 together before you guys try number 4. But if you look at number 3, we are not able to start graphing this right away. Can anyone see why we're not able to start graphing this in its immediate form? Yeah, hopefully you notice that this function is not written in y equals mx plus b form. So we're going to have to do that. What I need for everyone to do is take this function and solve it for y. Oh snap, didn't we already learn how to do this? Great. Okay, so we're going to solve this for y. We have x plus 4y equal to 8. We want to get this y by itself, so we're going to use the skills we learned last 6 weeks to solve for y. Move the x to the other side, cross the line, change the sign, then I rewrite down all of my terms. I'm going to divide each and every term by the coefficient of the y, which in this case is 4, so that I would get y equal to -1/4 x plus 2. Sweet, I've solved for y. Now that it's in y equals mx plus b form, I can start graphing. We start by finding our y-intercept. If the initial value is 2, that means my y-intercept is going to be at the coordinate 0, 2. That's its location on the graph where I begin for this particular graph. Now the slope is the coefficient of the x when it's solved for y. So I'm going to know that my slope is -1/4, which means I'm going to go down 1 and write 4. All right, let's do that. I'm going to go down 1 and write 4. I'm going to go down 1 and write 4. If I were to keep going, I would go off screen a little bit, so I'm just going to leave it there. That seems pretty good. So I have these new coordinates, it's off screen, that I can draw a straight line in between. I'm going to use a nice straight edge. I'm legitimately just using a nice piece of paper here, to draw my straight line. Voila, there's a nice straight line there. And we can label all of my function's attributes. Its x-intercept is all that I have left because I already know its initial value and y-intercept is right here at 2. Its x-intercept and 0 is where the graph crosses the flat or x-axis. I can see visually that this graph crosses the x-axis at 8, 0, which means that it has a 0 of 8. Boom, right there. This is awesome. Even though when we started this problem it was not written in slope-intercept form, we can go ahead and solve the equation for y, just like we learned before, and continue graphing appropriately, starting with the b and moving with the m. Alright, you guys have one more problem for me here. I would like for you to pause the video and try number 4. Graph this equation. You might notice that you have to put it in slope-intercept form first. Let's just take a quick check and make sure that you guys solve for y appropriately, because I don't want you to graph the wrong thing. When you solve for y, you should end up with the slope-intercept form y equals 1/3 x plus 2. Now that you know that it should be y equals 1/3 x plus 2, go ahead and continue trying to solve this, graph this equation for me. So this problem gets really interesting because if you do not actually plot this graph super accurately, you're going to have a hard time finding your x-intercept or your 0. You should have seen that the graph crosses the x-axis at -6, 0, which means that the 0 of this function is -6. But if you graph this even just slightly off, if you don't have a really, really good straight line that goes through all those points, you might accidentally answer -5 or -7. So to help that from happening, if you needed to work backwards, instead of going up 1, right 3, you can go down 1, left 3, down 1, left 3, and guarantee by following the same pattern, just working backwards, left and down instead of up and right, you can guarantee that you got this y-intercept correct, that it does cross the the x-intercept, that it does cross the x-axis at -6. So the goal of this lesson was to be able to physically graph our equations in slope-intercept form using our hands and a ruler, and then also talking about the attributes of these graphs, the slopes, the y-intercepts, initial value, x-intercept, and 0, which can all be found because they are places on the graph. See y'all in class.